Good morning, everyone. So, welcome to yet another discussion about quality assurance, instrumentation, and laboratory entrepreneurship. So, for this morning, we will be discussing about the um, laboratory statistics. So, I guess we already have started laboratory statistics last time. So, we had a short discussion about the descriptive statistics, about the mean, the median, the mode, the measures of spread, your standard deviation, coefficient of variation, to name a few. And of course, we already started to talk about the importance of laboratory statistics in quality assurance, in eventually in instrumentation, and of course, in laboratory entrepreneurship. So let's get started. So again, for this particular lecture, our goal is to define important terms in statistics, which we did last time, to differentiate descriptive statistics from inferential statistics. Later on, we will be starting our discussion about the inferential statistics or the comparative statistics already. Thirdly, to explain the importance of statistics in quality assurance, and of course, to calculate for you guys to be able to calculate the reference interval using the parametric and the non-parametric statistics. So let's get started. So for this particular lecture, I'll be discussing the reference range confidence limits, the calculations for your reference ranges, at the same time your comparative statistics and the method of validation and process control. So let's get started first with the comparative statistics. So last time we discussed about descriptive statistic. Now let's talk about comparative statistics. So comparative statistic aims in the this is the statistic that we apply if when comparing two set of means or two sets of standard deviation. So meaning to say we're trying to compare two different groups. Okay, we're trying to differentiate two different groups. So let's start with the t-test first. So the t-test is a test for the hypothesis. Okay, so it is used to determine whether there is a statistical difference or statistical significance between the difference between your means. So these are the means of two groups of data. So meaning to say we're trying to compare if their mean has a significant difference. Secondly, we have your F-test. Your F-test is a test used to determine whether there is a statistically significant difference between these standard deviations of two groups of your data. So that's what we're trying to compare. We're trying to compare the means if we are using t-test. If we're using your f-test, we are trying to compare the standard deviation of your two groups. Okay, I hope that's clear to everybody. Now, okay, before moving forward to the method of validation, which will be the longer discussion for this particular topic, let me reiterate it to everybody. According to William A. Foster, quality is never an accident. It is always a result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives. So again, in the clinical laboratory, there is no coincidence. Um, there is no accident in the clinical laboratory. We always want to remind everybody that quality is one of our utmost concern inside the laboratory. So now moving forward, let's talk about the method validation. All right. Well, let's talk about method validation and process control. So for this particular topic, we will be discussing reference interval and confidence limit. What are these ranges that we're talking about? And of course, we're gonna dig into the calculation of your reference range. So first and foremost, what is a reference range? Or in other terms, what is a reference interval? So a reference interval or a reference range is actually a pair of medical decision points that spans the limits of the result expected for a defined healthy population. So I don't know if you already have seen a reference range, but this is the a reference range or a reference interval is a group of data set. It is a range of medical decision points onto where we compare the patient's result. Again, this is where we compare the patient's result. Why do we compare it to the patient's result? Because the reference range or the reference interval, it's interchangeable, guys. You can say reference range or reference interval, that would be accepted. So the purpose of your reference range or your reference interval is to provide a medical decision point. When we say medical decision point, the physician, the one who will be interpreting the patient's result, would know what is the implication, what is the um, result all about. Okay, what the result is all about. So take for example, I have a particular reference range, so, and the doctors now would know if that patient is actually um, if that result was actually abnormal, normal, or if the patient is healthy. So perhaps most of you are asking, most of you are wondering, sir, why is it called, or why are we basing, or why are we even relying to the reference interval? So this is one very important thing that I want you to remember and understand and take into heart for the rest of your lives. So your reference interval was actually a decision points that was derived, okay, that was derived from a healthy population. So we later on will be discussing the process in establishing a reference interval or a reference range. But what I'm trying to say here now, sir, bakit ba doon natin binibase? Why are we basing our results, or why are we comparing our results to these reference ranges or reference interval? So it is for the sole reason that that reference range came from healthy population. All right, it came from a healthy population, so they now represent the 95% of the population. The 95% population. So having said that now, okay, having said that now, one very important consideration with regards to reference range is that it is the upper and the lower reference limits are always a set are set, okay, or are established to define a specified percentage of the values for a population. So usually what we remember in our previous discussion, we mentioned that inside the laboratory, we commonly use the 95% confidence interval. So what do we mean by 95% confidence interval? So we accept 95%, all right? We accept the results, the data of our population that are within the 95%. All right, that 95%. So your reference range or your confidence interval again is very important because um, it is from a specific population. All right, it is a specific population. So take for example, so I guess there was a question last time if reference interval are actually reliable, or if they are even paano sir kapag mali yung reference interval or yung reference range. That is the reason why later on we will be discussing how do we establish a particular reference range, or how do we establish a particular reference interval. So it is very important for us to remember that. But for now, what I want to inculcate in your mind is that your reference range, also known as your reference interval, is actually a set of medical points onto where we compare a patient's results so that we would know if they do belong to that 95% healthy population, or if they are outside that 95%, that would mean that there is some abnormality. Either the patient's results are so low, abnormally low, or abnormally high. So you would now be able to differentiate one from the other. You would now differentiate a particular condition from the other. Now, with regards to your reference range, one important terms that I also need to define to you guys is your is your confidence limit or your confidence interval. So your confidence limit is a range of value that include a specified probability. So usually 90% or 95%. But right now, I want to be more specific and say that inside the laboratory, what we are using is the 95%. This 95% corresponds to your plus minus what? Plus minus 2 SD. Okay? Plus minus 2 SD. So a confidence interval serves to convey the variability of estimates and quantify the variability. So this time now, okay, in the confidence interval, it is computed to include a parameter such as the mean with a stated probability, usually again within 95% that the true value falls into that interval. So let me just explain this to you. Okay. A confidence interval, okay, the confidence interval give us a 95% assurance, a 95% probability, a 95% confidence that when you measure a particular analyte, okay, take for example, I measured glucose and the patient's result was within the reference range, okay, within the reference range, how sure are we? Okay, how sure are we that our result was correct, or if we say na it is within the normal range, or it is within the reference range, the patient's condition is normal. How can we make sure of that? That is through the help of your confidence interval. So it gives us that 95% assurance na when you measure a particular um, when you measure a particular analyte, or when you measure a particular test inside the laboratory, you have a 95% assurance that the result that you got, okay, the result that you got was actually um, within, if it is within the reference limit, okay, we can say that 95% we are confident that that patient is really healthy. Okay, that patient is really healthy. So let me say it in Tagalog for the sake of our Filipino students. So allow me to say it in Tagalog, our dear international student. So ang ibig nating sabihin dito is that each and every time, okay, each and every time na may measure kang test. Like for example, nag-measure ka ng glucose. Kapag yung resulta ng pasyente mo ay nandun sa reference range, okay, reference range, gaano ka kasigurado? How sure are you that that result, when we say it is within the reference range, meaning to say it's healthy, there are no problems. So how sure are you that that particular measurement belongs to the to a normal interpretation? We have a 95% again na confidence to that. All right? A 95% confidence to that. So now, I hope we're clear with that. If not, I hope you can just rewind. Okay, rewind the video that you have right now. If not, you just ask me a question during our next synchronous class next week. So moving forward now, this is very important because a lot of the students, even those people already in the practice, okay, those people already in the practice, is actually confused with these two terms. Okay, these two terms that has been used endlessly, and people thought that they are actually synonymous. But right now, I want to debunk that assumption. I want to clear out that um, misunderstanding with regards to your reference interval and your normal values. So, moving on. What is a reference interval and what is a normal value? So let me explain it to you by saying that here in the Philippines, we are so fond of using the term normal values. Okay? So I guess I will be explaining and relating it to the reference interval shortly, since we already defined what a reference interval is. So let us go to the normal values first. So a normal value, okay, is a term used by most Filipino medical technologists and sometimes even other practitioners to actually denote your reference interval. What they're trying to pertain when they say normal values is reference interval. But why is it? Excuse me. Why is it, all right? Why is it that I am here now saying that these are two different things? And to be specific, you should never use the term normal values. Okay? You should never use the term normal values. Ayan. So Your normal values was used to denote that when a patient's result is within any reference range. So take for example, the range was 70, okay, 70 to 100, all right? If the patient's result was 70 to 100, so when the result is within 70 to 100, people will automatically say it is normal, okay? People will automatically say, okay, you don't need to go to your doctor, you don't need to return because your result is within this range, ergo, it is normal. Is that always the case? No. That is the reason why I am telling you now, ladies and gentlemen, my dear students, children, never ever use the term normal values anymore. Why? Because when we are using the term normal values, okay, normal values, it would just depict that a particular result is already normal. But that isn't that is not the case every single time. A more accurate term to actually refer to this range is not a normal range or a normal value, but rather by referring to it as a reference interval or as a reference range. All right? As a reference interval and as a reference range. Why is it so? Okay, why is it so? I will give you here, okay, I will give you three examples, okay? In three examples of the uses, okay? The uses of reference interval. And then later on, before I move on, I will interject this comparison later. So your reference range, all right? Your reference ranges or your reference interval can actually be used can intervals can be grouped into three main categories. There are reference interval that are used to diagnose a particular disease or condition. We can also have one a reference range used to monitor the physiologic condition of a particular patient, and third is to monitor therapeutic drugs. So as you can see, here are my examples. Okay, here are my examples. So the first table, okay, the first table, table 3-6, is a reference range for the diagnosis of the disease. Okay, for the diagnosis of the disease. So if the patient results are within the reference ranges, that would mean that the patient doesn't have the disease. Okay, the patient doesn't have the disease. But at the moment that the patient's result was below the lower limit or higher, okay, or higher than the upper limit, then that's the time that you would now proceed with other tests to check if the patient has the disease. This is actually the root cause unto why people have been calling your reference range as a normal range or as normal interval. Because automatically, people would assume that if they are within, okay, if their results are within this limit, they are normal. Meaning to say, they don't have the disease. Well, in that case, that is somehow partially true. Okay, that is partially true. But again, remember, we have different types of reference ranges. We also have one your for the monitoring of a physiologic condition. Like take for example, this is a reference range for the beta HCG that is used to define a gestational age. And here, okay, the point is this reference range here is used only in a particular condition. So meaning to say, 'di ba, if we're going to apply the mentality that we had here, okay? So meaning to say, take for example, I myself, I'll take myself as an example. I am a man, I cannot get pregnant, okay? I cannot get pregnant. But then again, okay, when we measure my beta HCG, of course, obviously, I will not even produce beta HCG in my body. And if we're gonna go into the terminology that we are using here, if all right, if I had if I had no beta HCG, that would mean that I would be lower than this reference rate, that than this lower ranges. So that would mean that I am abnormal. Okay, that would mean that I am abnormal, but in reality it's not the case, kasi I'm normal, because I cannot have beta HCG. I should not have beta HCG because that is the time that it will become abnormal. Are you getting my point there? So there are certain conditions, okay, like take for example in pregnancy, that we cannot say that it is this one is a normal range. This is not a normal range. These is okay. These are your reference ranges. Okay, reference ranges. So again, I hope you're getting my point when I am saying that we should not be calling it normal values. Aside from that, okay? Aside from that, and this one, I hope this would clear things out much better. So in table 3-8, all right, in table 3-8, this this reference range, it can only be seen, okay? Can only be seen in patients that are using your drug or you're using digoxin as your medication. So meaning to say, digoxin is only being used by whom? Okay, it is only being used by patients with um cardiac cardiac diseases, okay, cardiac diseases, because digoxin is a cardiac drug or a cardiac medication. So a normal individual that does not have your a healthy individual that does not have your cardiovascular disease, doesn't have cardiac disease, should not have digoxin in their blood in the first place. So are you getting my point now? Okay, are you getting my point now? Your reference ranges can be used in many ways. It can be used to diagnose a condition, to monitor a physiologic condition, and to monitor the levels of your therapeutic drug. And this is the very reason why we should not call it normal values. Okay? Normal values. Because if we would call it normal values, it would automatically imply that if you are out of this range, you are automatically abnormal. You automatically are um, you automatically have a particular disease. Take for example, in this particular one, okay, in the first table that we have, table 3-6, if you are out of the reference range or if your results are not within the reference range, that is the time when you will be considered or you would be undergoing further tests to verify if you do have the disease or you don't have the disease. But take for example, the levels that I had was 0.50. 0.50, or let's just take for the healthy adult na lang. For the healthy adult, take for example, my result was 0.06. In the clinical setting, okay, um in the clinical setting, the physicians will not simply just declare that the patient is normal if they saw that the the result of your patient was below this 0.60 exactly, they would actually still push through with other tests because somehow that is near the lower limit already. Okay, it is near the lower limit. It's just a matter of points. It will already be out of the reference range. All right, it will already be out of the reference range. So it's very important again to take note of this one. Okay, do not use normal range, do not use normal value, because there is no such thing as that. All right, there are only reference ranges. All right, there are only reference ranges. In addition to that, okay, take for example this table. If I am not within the range, if we are using normal value, I will be called abnormal already. Okay, but that's not the case again. Okay, that's not the case. So again, it's very important to use proper terms. So hopefully, right now I was able to differentiate the two to you. All right, I was able to differentiate that your reference interval is not the same with your normal values, and we should start getting rid of normal values. Kasi most of the time when people here now, they are within normal values, people would just tend to just live their lives again, not taking good care of their themselves. But take for example, if your value was already 100, so if that is being interpreted properly, okay, if that is being interpreted properly, there are some cautions that will be given to the patient because it's just a matter of points before your glucose level would be out of the reference range. And that would now imply a particular disease. So I hope you're getting me, huh? I hope you're getting me. So if you have any questions, you can actually post that on our discussion board. I will be providing you a discussion board for this particular topic. Now, the biggest question perhaps would be, how do we establish a particular reference range? How do we create a reference range? It is something, um, is reference range something that is already given and universal? Okay. The answer to that is no. Okay, the answer to that is no. So we do need to establish our own reference range. And when I say own reference range, it depends upon your age, upon your gender, upon your ethnicity, upon your ayan, background. Okay, so there are a lot of things that we need to consider in having a reference interval. So to make things clearer, okay, to make things clearer, take for example, the reference interval of Americans are not applicable all the time to Filipinos. Why? Because we do live in a different and in a different region. There are different environmental factors that might affect. At the same time, okay, at the same time, um, with regard to the reference range, your age, your gender, and even your ethnicity, your race, all right, your race would affect your reference interval. So again, not because you saw a reference range on the internet, not automatically you would apply that to your results. Why? Because again, you need to make sure, is that made for Filipino? Was that standardized for the Filipino? If not, you cannot use it. So in Bishop, all right, in Bishop and Clinical Chemistry, so on pages 72 to 86, it is being discussed. So on Bax 3-4, it is now a summary of how to establish a reference range study. So what is a reference range, or what is a reference interval? Again, this is a set of medical decision points onto where we compare our results. All right, it is where we compare our results. So the first thing that you would do is to define an appropriate list of biological variations and analytical interferences from medical literature. So let me just explain this to you briefly. So first and foremost, so take for example, I want to establish a reference range for the levels of the glucose. Okay, glucose of um, Filipino citizen. So Filipino. So the population is Filipino. So take for example, I have glucose. So the first thing based on Bishop is to define an appropriate list of biological variations and analytical interferences. What do we mean by that? Okay, I hope you're writing this down. So in number one, what you need to do is to list down, okay? To list down all the variations. What do we mean by biological variations and analytical interferences? These are conditions in the body. Let's talk about biological variations first. These are conditions in the body that might affect the levels of your glucose. Okay, when I say affect the levels of your glucose, it might cause your glucose to go low, or it might cause your glucose to increase abnormally. Okay, to increase abnormally. You don't have a disease, you don't have any abnormality. It's just that there was a biologic variation at that particular time. Take for example, diet. Take for example, your patient did not fast. Tapos they ate ice cream, chillin, ice cream. Chillin. Okay, so take for example, they ate ice cream um, before the blood extraction. So your glucose would tend to increase because of the ice cream that you have eaten. So I are you getting me, guys? So when we talk about biologic variations and analytical interferences, so we are talking about conditions, um, interferences. When we talk about interferences, these are the hindrances that might affect the measurement of your glucose. Okay, that might affect the measurement of your glucose. So later, by the end of this discussion, I'll be giving you a sit work. I'll be giving you an assignment so that you would understand what are biological variations and what are analytical interferences. All right. So having said that now, so after you have list down all the expected hindrances, expected possible sources of error, you would now proceed in the selection and partition. So what do we mean by selection and partition? So we are now talking about the selection of study individual. So important thing to remember here is to establish your own inclusion and exclusion criteria. It's similar to creating a research or creating a study. You only need to include patients. Okay, what are your inclusion? Why would they be included, and you also have the exclusion criteria. Again, let me go back to my example. Take for example, we are testing, or we are establishing a reference range for your glucose. What you need to do is to include patients that are only healthy. Okay, that are only healthy. So meaning to say, you will not be including. Okay, you will not be including here. Okay, you will not be including on your study patient that has diabetes, or that has hypoglycemia, or that has abnormally low glucose. So you would want to get the population that has a normal range of your blood, or a not a normal range, but rather a normal level. Okay, a normal level of your normal level of your glucose. In addition to that, all right, it is essential. Okay, it is essential to obtain the optimal set of specimens with an acceptable level of confidence. All right, acceptable level of confidence. So it's very important to always use this. Although this time, the level of confidence is almost constant. It is 95%, following plus minus 2 SD. What about partitioning? Okay, when we say partitioning, so we are differentiating. Take for example, if you would want to further classify the reference range, so you can have it by age. Ayan, this is a way of partitioning it. In this particular part, you partition it according to their according to the gestational age. Okay, according to the gestational age. So hopefully that is very important. Hopefully you were able to understand that very important part. Okay, so again, let me just reiterate, no, that the quality of your subjects would determine the quality of your reference interval. So what do I mean by that? So if you accepted in your study patients who are abnormal, or patients that do have a particular disease, you would be able to get a reference interval that is also erroneous. Okay? That is also erroneous. So it's very important again to what? It's very important that you choose the right population. Parang pag-ibig lang. It's like love. You need to choose the right person for you to be able to have a right future. Am I correct? Can I get an amen up in here? So it's very important for you to remember that. All right. So it's very important that the inclusion and the exclusion criteria should be strictly followed during the study. Why? Because it's very important. All right. It's very important. Now moving back. Okay. Number three. Okay. So some technicalities lang to. So they should complete a written consent form and a questionnaire to capture your selection criteria. So you need to interview them thoroughly, so you would know if they are qualified or not for your study, for the establishing of your reference interval. Fourth, you should categorize potential reference individual based on the questionnaire. So this is what I am talking about a while back about partitioning. Are you planning to partition them according to gender, the reference range for the male, the reference range for the female, or the reference range for adult, for infant, for fetus, whatever you want to partition them to. All right, and of course, you also need to have ex, exclusion criteria. So you don't just need not everybody that met your inclusion criteria are also qualified. So you also need to have an exclusion criteria. Okay? Okay? So number six. So, okay, so we also need to define the number of reference individual in consideration with the desired confidence limit and statistical statistical accuracy. So this is a more this is a statistics part. So usually, okay, in the reference interval study, we are having 120 samples. Okay, a minimum 120 samples. The more samples, the better. Okay, the more samples, the better. Because it would, remember in statistics, di ba? We are just getting a sample eh. But if you can get a bigger number of samples, a bigger or ideally an entire population, that would be easier. Okay, that would be better. Okay, that would be better. Okay, so moving forward, so again, it's very important. So usually the number is 120 120 subjects or 120 participants. Number 7, it's very important to what? Standardize collection and analysis of reference specimen for the measurement of a given analyte consistent with the routine practice of your patient. So here comes now your pre-analytical and analytical considerations. Remember when I was talking to you about the general workflow inside the laboratory. So there are pre-analytical and analytical considerations. This is number one. All right. This is number one that I want you to remember with this matter, that it needs to be controlled and it needs to be standardized. So what do we mean by that? How you treated patient sample number one should be the same with the 120th sample. Nagigets? How you treated, how you handled, how you collected, how you tested patient number one, okay, reference subject number one up until reference subject number 120 should also be the same. Aside from that, how you process, okay, when we are saying kasi reference subject, this is the 120. Okay, this is the 120. Okay, the reference was the 120. So this is now being compared to your patient, right? This is being compared to your patient. So for it to be applicable to your patient, the process that you did here should also be the process that you did here. So if you collected it at 8 p.m., you collect the patient at 8 p.m. So similarly, if you collected the blood at 8 p.m. in patient number 1, patient number 2, 3, 4, 5 until the 120th sample, 120th patient, their sample should all be collected at 8 p.m. Okay? At 8 p.m. I hope you're getting me when I say it's controlled and standardized. So you also need to define acceptable interferences. So what do we mean by that? Remember that when we are following a 95% confidence interval, how many percent of errors are we allowing? To approximately 5% error. Okay, 5%. And we need to define what are those errors that we are going to accept because they are somehow inevitable in your testing. Okay, inevitable in your testing. But most importantly, each and every one of you, specifically those who will be performing reference interval studies, they should have an extensive knowledge regarding the analyte, meaning to say they have an extensive knowledge about glucose. What are the factors that affect the level of your glucose? What are the factors that would cause it to be falsely high or falsely low? You also need to know the analytical parameters, the different methods that would be used optimally to measure the sample, and also the instrumentation, the materials or the apparatus that you will be using in the measurement of your glucose. This one will be part of our discussion in the coming weeks. Okay, so always remember that it should be controlled and standardized. This is important because once that there is a difference on the treatment of your subjects or your sample, it will already compromise your reference interval. So how you treated patient number 1 should be your treatment until patient number 120. Okay, so this is an example of your pre-analytical factors that you need to consider. So I want you to remember this. So you need to consider patient preparation, prescription medication, collection time, when will you be collecting the sample storage, will it be on um, room temperature, at body temperature 37 degrees, or simply at a refrigerated temperature of 4 degree centigrade or lower. So stress, beverages, so all of those you would also try to consider with the analytical factors, precision, accuracy. I guess you all know these already: lot to lot reagents, linearity, interference, and recovery. Now, having said that, determining whether to establish or verify your reference interval would need to be on your would need to coincide, or would need to agree. Okay, so if the correlation coefficient is 1, as the slope is 1 and the intercept is 0, the method agree and may not require a new reference range. So take for example, there are two reference range that you are trying to compare. Am I going to change it or not? So if this is the case, 1.0 and then as intercept of 0, meaning to say there are no significant difference between the reference range that you are trying to impose today compared to the older one that are already being used. Okay? Already being used. So it's very important. So you need to identify again if you would now be applying, or if you would now be establishing the reference interval. Sir, what if the correlation coefficient is not equal to 1, this is not equal, the slope is not equal to 1, and the intercept is not equal to 0, then that's the time that you can establish a new reference interval, because again, the former one is no longer applicable. Okay, the former or the old reference range is no longer applicable now. So very important consideration in doing data analysis to establish a reference interval: the study should have at least 120. Okay, it should have at least 120 samples. So 120 individuals, also synonymous. Guys, it is the same, parehas lang. When I say 120 subject individual, 120 subject, or 120 reference individual, or reference subject. We add the term reference to denote that that individual, those patients, are actually the reference individual, meaning to say the reference interval will be coming from them. Okay? So reference interval is calculated statistically using methods that depend on the distribution. Okay? Again, it depends upon the distribution. This is where one of the things that I was trying to explain to you last meeting, that if the distribution is normal, then you would be using a parametric statistical tool, or the parametric method. On the other hand, if we are now using, or if the distribution are not normally distributed, meaning to say it is skewed, so that would mean, okay, that would mean that we need to what? That would mean that we need to use your non-parametric method. So let me just try to explain it to you further by trying to draw, okay, trying to draw with all my best how a normally distributed and a not normally distributed, um, not normally distributed, um, not normally distributed data would look like. So, okay, sorry for that. So now, okay, now this is how a normally distributed data would look like. So as you can see, it is normally distributed. It follows the Gaussian distribution. Unlike your abnormal, your not normally distributed one, so you can see that it is already skewed. Okay, this one is already skewed to, so either to the left or to the right. So meaning to say they are not normally distributed. So again, it is very important for you to remember, if it is normally distributed, we follow the parametric. If not normally distributed, we follow the non-parametric method. Okay? The non-parametric method. So I hope we're clear, ha? So the first part that I was mentioning to you guys, this one, this is the considerations before you compute. Okay? So take for example, you already have all the data, you already collected samples, you already measured them. Now, we're ready to determine, okay, we're ready to analyze the reference interval. So again, when we are talking about non-parametric method, so statistical test that makes no specific assumption about the distribution data. So non-parametric method uses rank. Okay, they rank the reference data in order of increasing size. So because majority of the analytes are not normally distributed or not in Gaussian distribution, so non-parametric tests are recommended. Okay, non-parametric tests are recommended. If it is parametric, meaning to say the statistical values, the statistical data follow. Okay, they do follow a normal distribution, a Gaussian distribution, then we would be using a parametric method. A parametric method. So let me try to share this one to you now. So take for example, we have this one. So we are following technically 1.96 SD. So depending on the problem. So parametric method defines that the interval by the mean um, can be computed using this formula. So very easy, correct? So very easy. So what you need to do is to just substitute the given. So this is the sample data. Okay, this is the sample mean, rather the sample mean, and then you would just simply add and subtract 1.96 and the product of it with your standard deviation. So how does it look like? So my let me now start sharing my screen to you so that I can give you an example of the computation. So, okay. So, I hope everybody are now seeing my screen. Okay. I hope you guys can see my screen now. So, let me just proceed to my notes. So, there you go. So, for this particular one, again, we're doing the non-parametric. Okay. Rather the parametric mode. The parametric. Again, when do we use the parametric? When do we use the parametric? If the data are normally distributed. Okay? Normally distributed. And how does it look like? How does a normal distribution look like? It looks like this. Okay? So kahit pangit yung drawing ni Sir Ganding, this is a normal distribution, correct? This is a normal distribution. And what is the formula for that? That is x, or the mean, okay, x bar plus minus 1.96 times your SD. Okay, you would simply multiply it. Okay, you would simply multiply it. So for the lower or the yeah, for the lower range, okay, for the lower range, isn't it you have your upper and lower range for your reference interval? For the lower range, the formula is x bar minus 1.96 times your SD. For the upper range or the upper limit, okay, upper range, the formula would be x bar plus 1.96 times SD. So take for example, we have a particular example on the screen. Example is the data. It was mentioned to be normally distributed. Okay, normally distributed. So that is already okay. That is already the number one distribute. Okay, normally distributed. So that is the number one thing that you need to check before you proceed. So take for example the mean. Okay, the mean is equal to 6.6 55, and then the standard deviation is a total of 1.360. So you simply substitute the given. Okay, so simply substitute the given to the formula. So how do we get that? So for the lower range, so you need to just substitute it 6.655. This one's minus. Okay, subtract it by 1.96 times SD, which is 1.360. So simply compute that. So that is a total of 6.655 minus, let's try to compute that. Okay, it's okay to use your calculator because I myself is not very well in mental math. So 1.96 times 1.360. So that is minus 6656. Okay? 6656. So now let's subtract it from 6.655 minus 6.655. Okay, so 6.655 minus 2.6656. So that is a total of 3.9894, or approximately, let's follow a two decimal places rule. So that is 3.99. Okay, that is 3.99. Hold your horses. That is just one number. That is not yet a range. Okay, so what about the other half? Okay, the other half for the upper limit. So same thing, 6.655, okay, plus 1.96 times 1.360. So 6.655 plus 2.6656, so that the total would be 6.655 plus 2.6656. That is a total of what? That is 9.3206 approximately. That is 9.32. So you already have your range. So the reference range, all right, the reference range would be 3.99 to 9.32. Okay, always remember the unit of whatever was given. So take for example, the mean given was in milligrams per dl. So the reference range now will be 0.99 to 9.32 milligrams per deciliter. So there you go, guys. This is already your reference range. So I hope that's clear. Isn't it? It's easy. Pero why are students having a hard time with this? Because they fail to identify what is normal and what is the not normally distributed. Okay? Not normally distributed. So usually, okay, I'll give you clue. Okay? How can I question is, how can I identify if it is normally distributed? Okay? Number one, okay? Number one tip, ladies and gentlemen, I hope everybody's listening. Number one tip is on the word problem. Okay, on the word problem. So you need to look for the keywords. Okay, look for the key words such as what? The keywords here are Gaussian distribution. Okay. Aside from that, take for example, um it is normally distributed. Okay. Okay, normally distributed. So they can say that the data sets are following the Gaussian distribution. Okay, or they can say that the data are following that the data are normally distributed. Aside from that, okay, aside from that, how can you determine it pa? Aside from that, you can also determine that using what? You can also determine that using your drawing. So using your drawing. So an example of that is this one. So the data should look like this. Okay. So if your data actually look like that, then that goes to show that the data that you are actually dealing with are normally distributed. Okay. They are normally distributed. Now, moving forward. Okay, can we move forward? Okay, now moving forward, let me just return back. Okay, let me just resume my presentation. So, on the other hand, what about a not normally distributed? Okay, not normally distributed. What are we going to use, children? What are we going to use? We're going to use your non-parametric. Okay, so in your non-parametric, it's actually quite complicated if you would look at it. But do not worry, I got you. So we'll just try to explain it direct to the point. So always look for this one. I always want you to look for if the confidence are we are looking at the central 95% of the values. So if the reference interval or the confidence interval rather is 95%, we would be following the 2.5 2.5 and the 97.5 percentiles. Okay, the 97 percentile. So it is very important for you to remember this because here we're not basing it on the mean, we're not basing it on the standard deviation, but rather on the number of reference specimen. So when we say reference in specimen, these are the number of subjects, the number of participants, or the number of patients that are actually there during the study. So take for example this one. So assuming that this actually followed 120. Okay, they actually have 120 patients. Okay, they actually have 120 patients. So if they have 120 patients, so what you will be doing is to actually simply substitute it. Okay, you will simply um substitute it on your you would just simply substitute that on your data. So take for example the 2.5. Okay, that is 2.5%. So you would convert that to your decimal to its decimal form, that is 0.025%. Okay, 0.025%. And then okay, that is now equivalent to what? That is now equivalent to this would now be equivalent to 0.025. So you would now divide it. Okay, you would now divide it. So take for example 0.025 times n again is the number of reference interval plus 1. So always remember the plus 1. So this is for the 2.5 percentile. Okay, this is your lower limit. Ay, your lower limit. And then for your 95.75, that is now your upper limit. Okay? I hope that you quite get me with that, no? I hope you quite get me with that. So again, if it is a 2.5 percentile, that is for your lower limit. And again, if it is a 97.5, okay, that is now your upper limit. So let me try to again demonstrate it to you, ladies and gentlemen. Okay. So I hope my pen would work. Okay. So let me just do it quickly so that I'll be able to explain it to you. And so going back now, okay, going back to our figure kanina. What about for your non-parametric? Okay? For your non-parametric, what happened? In your non-parametric, what are the keywords here? They are skewed, okay? Not normally distributed, normally distributed. And aside from that, not following the Gaussian distribution. Are you not following the Gaussian distribution? So if this is the case of your data, if this is the case for your data, then you would know that, oh, it's time to use the non-parametric. And what is the number one ano there? 95% interval. Okay, the 95% interval would mean that you would be getting your lower limit and your upper limit from what? Your lower limit will be coming from the it will be coming from the 2.5%, okay, 2.5%, and then the other one is 97.5%. Maybe some of you are wondering, sir, bakit 2.5 at bakit 97.5? I want you to remember this. 95% means 95% error. Okay, 95% error. And if we're going to divide that, okay, so syempre, meron ka sa dulo, meron ka sa kabila. So that is the 2.5% error and the other 2.5% error. The 2.5% error, so from 0 to 2.5, that is already the error. And then from 90, this one on the other end, from 97 point, take for example, 97.6 until 100, those are already the excluded. What you just want to follow are the one within this is that is a total of 95%. But now, hopefully I was not able to complicate that thing to you. Let us just focus on the computation. So the lower limit, okay, if it is non-parametric, okay, we're talking about non-para ha, non-parametric here. The lower limit would be 2.5, okay, percent, correct? So that is 0.025% times n plus 1. For the upper limit, that is 97.5, okay? 97.5, correct, 97.5. And so, having said that now, that is 0.975 times n plus 1 for the upper limit. So take for example n. Okay, what is n again, mga kapanalig? N is equal to the number of samples or subjects. Okay? Ayan siya ha. Always remember this. Okay? So that is N. So take for example, you have a problem. So assuming that the confidence interval is 95%, which will always be the case, okay? Which will always be the case, 95%, and the N is, take for example, 120. So simple. You just substitute N. So that is 0, okay? So 0.025 times n plus 1, that is 0.025 times 120 plus 1. The other one, okay, so let's compute that. So that is 0.025 times 121. So what would be the answer? 121, okay, 121 times 0.025, what would be the answer? Okay, 121 times 0.025, the answer is 3.025. Okay, 0.025. And then for the upper limit, ganun din. 0.975 times n plus 1. 0.975 times, substitute the value of n, 120 plus 1. 0.975 times 121. What is the answer? That is 0.975. That is 117.975, or approximately 117.98, and this is approximately 3.03. So the reference range, okay, the reference range, okay, of the non-parametric data, non-para data is 3.03 until 1.17.98, take for example, milligrams per deciliter. So this would now be the reference range. Okay? So simple, correct? It's very simple. So all you need to remember is to effectively identify or to efficiently identify, is it a parametric or a non-parametric? Ano ang kailangan kong gamitin? Parang pagmamahal, kailangan ko bang gamitin this time ang puso? Kailangan ko ba gamitin ang aking isip? Okay? So it's a case-to-case scenario. So hopefully I was able to clear that out to you guys ha. So remember the keywords, remember the formula. The formulas are very easy to follow. The gist here now, the difference would now be on how you identify if it is a parametric or a non-parametric. Again, for parametric, normally distributed, Gaussian curve, okay? This one, pag sinabi nating non-parametric, it is skewed, they are skewed, not normally distributed, not following the Gaussian distribution. Okay? So having said that now, okay, having said that now, so by the end of this, you are now able to compute your, you were now able to compute, okay? You were now able to compute the values, okay? You were now able to compute the values of your data, okay? The values of your data or the reference interval for your particular test. Now, let me talk to you about the data analysis to verify reference interval. This is different from your reference interval study because this is what we call transference. Okay? Sir, what is transference? I'll give you a scenario. Transference is the procedure that you do if you don't want to perform an entire test and you just want to adopt a particular reference interval. So take for example, I I just established my own I just established my own I just established my own clinical laboratory, and I need to and then I need to perform, or I need to set my reference interval. I don't want to do the long process anymore. I don't want to go through this anymore. Okay? Is that possible, sir? It's possible if you would use previously used reference interval. Parang ang gagawin mo dito, you would copy a reference interval. Sir, is that allowed? Yes, it is allowed for as long as you would follow the process of transference. What is transference? So in transference, so the CLSI allows you now, the laboratory, to use less vigorous study to verify a reference interval. Okay? To verify a reference interval. So take for example, you want to put up a reference interval pero you just want to copy, you do transference. So instead of 120, you would just be testing 20. Okay? You would just be testing 20 subjects minimum. Okay? Minimum 20 subjects. So the process would be like this. So what you would do instead of 120, parehas same process. But the thing here is that here's the thing. So you would only be performing it to only 100 to only 20 samples compared to the reference one, okay, compared to the one that we were talking about, you do it at 120, okay? You do it on 120 individuals. This time, no, sabi, I will only be using 20 samples, okay? 20 samples. So here's the thing, okay? So if less than 10% of the 20 samples that you had, okay, 20 samples that you had was only less than 10% was outside the range. So meaning to say outside, meaning abnormal, then you can automatically use the reference interval that you had. So take for example, I was testing if 70 to 100 is applicable to the Filipino living in Mindanao. Okay, I took this from the reference range from the Filipino living in Luzon. So I want to standardize it. So I did the test to 20 subjects, to 20 reference subjects, and then only less than 10%. If only less than percent, then well and good, you're free to proceed. You can use the 70 to 100. What if naman, on the other hand, you failed to reach that standard? Greater than 10%, greater than or equal to 10% was outside the range. So what you need to do is to repeat the test again. So you would be repeating it to another, okay, into another 20 specimens. So this is another 20 specimens. So another 20 specimens. So now, if your data was only having less than 10% of error, then well and good, you can now use the 70 to 100. Are you getting me? But what if, okay, what if there are still greater than 10%, okay, errors or outside the range? What will you do? Okay, what will you do? So you would now need to perform the entire thing. Okay? The entire thing. So when I say entire thing, you need to perform the reference range study, the reference interval study using 120 samples. Okay? So madali lang naman siya intindihin, correct? It's easy to understand. Again, if you were able to get it right the first time, then you can use it immediately. If not, do it another again to another 20 samples. If it worked, then you can use it. If not, if you still fail, okay, if there are still error, then that's the time now that you would be performing it again to 120 samples. Okay? To 120 samples now. So I hope I made myself clear with that. But before I proceed, I want to reiterate this part na you should copy, okay? You should copy a reference interval that has a 95% confidence interval, or a plus minus 2 SD. Okay, a plus minus 2 SD. So 95% confidence interval. So the reference interval can can be from your literature, from the books that you read, or from the manufacturer. You want to adapt that, that's perfectly fine, for as long as you follow transference properly. Okay? So what if after that I still failed? Okay, so you need to perform, or you need to establish your own reference interval talaga, because it might actually signal that it's not applicable to the population that you want. Okay, so I hope that's clear. Now let's proceed to this would just be quick na lang. Okay? So now let's proceed to the methods of validation. So let's just explain what is accuracy and precision. So accuracy, it is the nearness or the closeness of the assay's value to the true value. So there are different tests that we can do. Okay? Different tests that you can do to estimate accuracy. So you can do recovery study, interference study, patient sample, and even comparison, patient sample comparison. So precision, on the other hand, this is now the ability of an analytical method to give repeated results on a sample, on the same sample, that agree with one another. So if we would illustrate this, okay, this is an example of imprecision and inaccuracy. Okay, imprecision and inaccuracy. This is an example of inaccurate but is precise. So this is one of the examples that I was giving you last time, that it is possible that your samples are actually precise but they are inaccurate. But most of the time, if your samples are all accurate, if they are all accurate, they are also precise. Okay? So having said that now, having said that now, um what's next? Okay, having said that now, what's next? So let's talk about the analytical sensitivity and analytical specificity together with the predictive value. So collectively, we call them the measures of diagnostic efficiency. Okay, diagnostic efficiency. So this is the ano this is the what do you call this? This is the measures of diagnostic efficiency. We have your analytical sensitivity, analytical specificity, and predictive value. So I want to clear this out because this is very important. So when we talk about analytical sensitivity, so this is the ability of an analytical method to measure the smallest amount or the smallest concentration of an analyte. So usually this should be um, high sensitivity, okay? High sensitivity should be on your screening test. On the other hand, when we talk about analytical specificity, it is the ability of your analytical method to measure only the analyte of interest. So this is very important for your confirmatory test. So let me give you an analogy. In your analytical sensitivity, it should be on your screening test. So meaning to say, your screening test should be able to measure the smallest or the least amount or the least concentration of your analyte. So take for example, for your COVID-19 now, okay? Take for example for your COVID-19. For a screening test, we need to have a screening test a um, that has a high sensitivity. Why? Because um, we need to detect all cases of COVID-19. Because if the sensitivity of your screening test is very low, you might actually have patients, okay, misdiagnosed, being false negative. Okay, so there would be patients that are false negative. Okay, so again, that's what I want you to remember, ha. When we are talking about analytical sensitivity, smallest concentration, it should be a characteristic in your screening test, high sensitivity for your screening test. On the other hand, analytical specificity, this is the time now that the test should only measure the analyte of interest or the substance of interest. So take for example, there are a lot of coronavirus. So if I want to confirm the test, what would I use? Your RT-PCR. Your RT-PCR is considered to be a confirmatory test because among all of the tests, it is the one that has the highest specificity. So what do we mean by high specificity? When your machine measure, it can only measure SARS-CoV-2, okay, and not other coronaviruses. There are a lot of coronaviruses, correct? So you would only measure, okay, the ones that has the SARS-CoV-2. Like for example, may SARS-CoV-1, okay, or your MERS-CoV, your MERS-CoV are all there. If your tests are not specific, you would all measure those three. But if your confirmatory test is very much specific, you would only be measuring the analyte of interest. So again, screening test should have high sensitivity and your confirmatory test should have high specificity. So please take note of their definitions. Now, okay, please take note of their definitions because we have a very much similar sound. They actually sounds the same, okay, but are entirely different. So we have your diagnostic sensitivity and the diagnostic specificity. Okay, so the diagnostic sensitivity is the ability of the test to detect a given disease. Okay, meaning to say they are able to detect individuals with the disease. Okay, individuals with the disease. In diagnostic specificity, you would now correctly identify those individual without the disease. Sensitivity with the disease, diagnostic specificity without the disease. Now let me clear this thing to you. Sir, can I just simply say sensitivity? Can I just simply say specificity? If you are talking about the analytical one, that's acceptable. That's good. But if you are pertaining now to diagnostic sensitivity in diagnostic specificity, it's a different thing already. So you need to be complete. When we say when you are pertaining to the ability of the test to detect the lowest concentration, we call that analytical sensitivity. But if we're talking about now the ability of the test to detect the disease, that is now or the individuals with the disease, that is now diagnostic sensitivity. If we're talking about the ability of the test to detect only the analyte of interest, that is what? Analytical specificity. Now, if we're talking about the ability of the test to correctly identify individuals that do not have the disease, what do we call that? That is diagnostic specificity. So again, your diagnostic sensitivity is the proportion of individuals with the disease, okay, that will test positive. And in diagnostic specificity, these are the proportion of individuals that will be negative. They do not have the disease. So as you can see, okay, in the formula, diagnostic sensitivity is the number of the true positive, okay, over the false negative. So let me share my screen to you once again so that I can explain to you what is true negative, true positive, and false negative. Okay, so I'm nearing the end. This is actually the last part of our discussion. Okay, so let's talk about the true positive and the true negative. Okay, let's just try to have it na lang ng ano, in column. Okay, so true, negative. Okay? So when we say true positive, okay, these are individuals, okay, individuals with the disease. Okay? And plus in the test, they are positive. So what do we mean by that? They have the disease and the test was successfully, okay, was correct in identifying that they have the disease. What about true negative? These are individuals without the disease. Okay? And the test tested Okay, the test, it tested negative. So meaning to say, when we say true positive, yung may sakit, na-detect mo talaga na may sakit. In English, for the sake of our international students, a true positive result is when your analytical test, the test, was able to detect those who have the disease. So take for example, the individual do have the disease, and the test reflected the same as well. So the true negative is the other way around. You don't have the disease and the test was also negative. Perfect. In Tagalog, wala kang sakit. Sa test, negative ka. Perfect. Now, what about false positive? Okay? False positive and false negative. Okay? So, I want you to join me here, ha? So, this time, false positive, okay? These are now individual without the disease. But in the test, okay, during the test, they were positive. So we call this false positive. Okay? So this is a no-no. Correct? So what about the false negative? So these are individual. Okay, individual with the disease. But what's the problem? The test result was negative. Okay, the test result was negative. Is this good? Of course, no. Why? Because there will be patients that do not have the disease that will be misdiagnosed. And there will also be patients that does have the disease that will also be misdiagnosed. Now, what is the importance of the true positive and the true negative? These are important, okay? So true positive, true negative, false positive, false negative. These are very important because these are the one used. This is TP, this is TN, FP, and FN. So these are used in the computation, okay, for diagnostic sensitivity and diagnostic specificity. Okay? Specificity. Okay, specificity. So for diagnostic sensitivity, okay, remember, okay, sensitivity, our focus here are the positives. Okay? Our focus here are the positives. So what is the formula? So the formula, ladies and gentlemen, for diagnostic sensitivity are the true positive all over. Okay, the true positive plus the false negative. Because this false negative do have the deceive. Do, okay, let me just change the word here so that you understand it better. Okay, this is individuals. Okay, these are individuals with disease. Okay? So this is the formula ha. True positive plus false negative. What about diagnostic specificity? Okay? These are individuals without disease. So we're talking about the negatives. So these are true negative all over true negative plus false positive. Okay? Plus false positive. So having said that now, okay, having said that now, can we compute it? Okay, can we compute it? Yes. So take for example, I have a table here, ha. I have a table here. So take for example, I have the true positive, okay? The true positive and then the true negative, okay? Uh-huh. Uh, let's put it on the other end. Okay, true negative. So like for example, I have this, okay? And then I also have here the um, false false negative and false positive. So that's the table. So take for example, the values are, take for example, this is 8. Okay, this is 2. Okay, these are 8. These are 2. Okay, and then for this one naman, this is actually 3. Okay, this is 3, and this is um, the false one. Or wait lang. Nagkagulo na yung ano ko. Oops. Okay, take for example, this one is true positive. This is your false negative. So this is 2, okay? And then this is your true negative. Okay, the true negative were just 7, okay? And then the false positive was 3. So how will you compute it? So ganun lang, substitute for diagnostic sensi. Okay, the formula, lahat ng nasa taas, 8 plus 8 plus 2, 8 divided by 10, that is 80%. For diagnostic specificity, okay, that is in percent guys ha. So that is 7 over 7 plus 3. So 7 over 10, that is 70%. So you have a test that has 80% sensitivity and 70% specificity. So kita, it's just a simple mathematics. Okay, it's just a simple mathematics. Again, let me resume. Okay, so for the sake of our discussion, so this is how it looks like. Okay, so this is how it looks like. So okay, so moving forward. Um, Moving forward, so that is the ano ha, diagnostic sensi, diagnostic specificity. Again, please refer to the video that we discussed. Now let's go to the predictive values. Okay, in the predictive value, the predictive value can be positive or negative. So positive predictive value, this is the percentage that when you had the test, you would test positive, and the negative predictive value, this refers now to the probability that a patient who does not have a disease would test negative. The predictive value. So positive predictive value refers to the probability of an individual having the disease if the result was actually positive. So how sure are we? That is the answer now of your predictive value. How sure are we that they are positive? How sure are we that they are negative? So this is the predictive value. So we are also gonna use the same problem. So the true positive was 8 and the false negative was 2. False positive was 3. The true negative was 7. So the formula will just be a bit different. Okay? So isn't it? Let me just compare the formula. No? Here, you combine true positive all over true positive and false negative. Here, true negative all over true negative plus false positive. And the predictive value, all the positives and all the negative would come together. So true positive all over true positive plus false positive. The negative predictive value, true negative all over true negative plus false negative. So I hope that's clear ha. It's just the matter of formula. So true positive all over true positive and false positive. So no need, because in our future exams, in our quizzes, you will be given a data set. You will be given a data set, and what you are going to do is to simply identify which is which, and to simply substitute the formula. So again true positive can also be quoted in the exam as individuals with the disease. Okay? And without the disease, that is true negative. So that is it for today. So that is diagnostic efficiency. So hopefully I made myself clear with that. So we already spent 1 hour and 30 minutes for our video. So um I will not be giving you any seat work that you need to submit. But please remember that next meeting, okay, on our next meeting next week, we will be having your long quiz. Okay, so please check the TLC for the entire coverage of the test. Again, please check the TLC for the entire coverage of the test. So having said that, now thank you so much for listening. So again, I will be providing a discussion board for your questions. So thank you so much for listening. So that is it for today. That is all about the diagnostic sensitivity, specificity, and overall that is laboratory statistics. Thank you so much for listening. This has been your Sir Jomar Ganding. Thank you so much for listening, and I will see you guys next week. Thank you so much.